Hello guys, my name is Lazaro and today we're going to be going over a medium LeetCode problem. This problem is called maximum binary tree. You're given an integer array nums with no duplicates. A maximum binary tree can be built recursively, that's a good hint right there, from nums using the following algorithm. Create a root node whose value is the maximum value in nums. Recursively build the left subtree on the subarray prefix to the left of the maximum value. And then pretty much the same thing, recursively build the right subtree and then subarray suffix to the right of the maximum value. And then you just return the maximum binary tree built from nums. So this is a little confusing. Let's look at the example. We're giving, this might make things worse, but I'll break it down. We're given nums, which is an array of integers. Right here, we can tell that we have to find the largest number, and then with that largest number, we create the node. So right here, the largest number is 6, which is why 6 is our root node. And then everything, all the numbers to the left of 6 will be used to create this 6 nodes left subtree. So this 3, 2, 1, it will be used to create this left node right here. But it would choose the largest number from this 3, 2, 1, which in that case is just 3, which is why its left node is 3. And then when the 6th node, it will also do the same thing for the right subtree. It will use every number to the right of the 6, which is 0 and 5. And then this right node will have a value that's equal to the maximum value inside of this array, this 0, 5 array, which in this case is 5. So I just explained the first level and the second level. I'm going to go ahead and now start working on the intuition. I could do more. I could also explain how they got 2, 0, and 1. But let me work on the intuition where I will draw it out and it'll be a little bit better than just talking about it. So right here, this is our array called nums. From this array, we want to get the maximum value and set that equal to the node. So right here, the maximum value is 6. So we create a node with 6. The left node of this 6 is going to equal everything to the left of 6, which is this 3, 2, 1. And then from here, this left node is going to have a value that's equal to the largest value inside of this array, which is the 3. Now, 3's left node is going to be equal to everything to the left of 3, which is empty. So this is none. And I'm going to leave this here. I'm not going to write a number. I'm not going to give it a value. So just remember, since it doesn't have a value, it's basically equal to no. Right? You know what? There, perfect. Now, the right of this 3 is going to be this subarray, the 2 and 1. From there, we do the exact same thing and we choose the largest value in this new array, which is 2. Now, this 2's left node is going to be equal to an empty array because everything to the left of the 2, there's nothing left. So it's just going to be equal to an empty array and the values will be null. Now, everything to the right of the 2 is going to be just 1. And the largest value in this array is 1. So now we completed everything to the left of the 6. So we completed the 3 and the 2 and the 1. Now we have to do the exact same thing for everything to the right of the 6. Okay, all right, perfect. So pretty similar to the 3, we now have a new array. we have the 0 and the 5. Now the value of this right node is be the largest one, like we've been doing this whole time, which is 5. Now everything to the left of the 5 is used to be the 0, so it is going to have a left node, and this is be equal to 0. And the largest value in this array is just 0. Now, I can also do the left and just write no, but I'm not going to do that. Because we know after this, it's just going to be empty for both. Now, everything to the right of 5 is just going to be empty array, which is going to be equal to no. Because there's no numbers to the right of 5. And this is exactly it. This is the exact same answer they want. We have the 6, 3, 5, 2, 0, and then 1. 6, 3, 5, 2, 0, and 1. Only difference is that I actually wrote down no so you guys can visualize it, but now let me delete it. Go. Perfect. So now if I were to move it like this, 6, 3 is to the left, 5 is to the right of 6, perfect. 2 is to the right of 3, correct. 1 is to the right of 2, correct. And 0 is to the left of 5, correct. So this intuition does help, and it does work. So we know every time we get an array, we have to find the maximum value, find what value is the maximum inside the array, find the position that maximum value is at, and then create that node, that maximum number, and then everything to the left, do this recursively. So we build out its left subtree with the new array. So that's how you can tell we can do this recursively, because we're using the exact same logic every single step of the way. Every single time we create a node, we want to find the maximum value and its position. And then for every single node, we're going to pass its left and right a new array, which is a subarray of the current array we're on. For example, this 3 here, it's left. We got this 3, 2, 1 array. We found the maximum, which is 3, and the maximum position, which is 0. And then we could create a left node from everything before the 0 position. But everything before the 0 position is just an empty array. And then we could create its right node with everything after the 0 position, which is going to be position 1 and 2. So this is why we can do this recursively. We have the exact same logic everywhere. Now, how would this recursive function look like? Well, since we already got the intuition or how to solve this problem, and we thought it out, and we thought about the logic behind it, let's start working on the code and see how we can build this recursive function out. So let's create a method, let's create a function. Let's call it recursive. And this is going to take an array, and it's also going to have a tree. And this tree is how we're going to build out our tree. Now inside this function, since we're doing it recursively, that means within this function we're recalling itself. Let's create a base case. A base case is basically saying, when should we stop this recursion cycle, this recursive cycle? Well, we should stop when the length of our array is empty. When the length of this array is 0, we have no numbers. And we cannot possibly build a node with an array of 0. So when it is 0, let's just stop. Let's just return. So if array.length, if it's less than or equal to, now I'm just being safe here. most likely will never happen. It will never be less than 0, but it doesn't hurt. So when the length of that array is less than or equal to 0, let's just return the tree. Let's return what we've built, whether we built something or not. Perfect. Now, if this is not the case, that means we do have a number in our array. If we have numbers in our array, we need to find the maximum and we need to find the position that maximum number is at. So, max number, let's set this equal to negative infinity. The reason we're doing negative infinity is even inside our array, let's say we have negative 5,237 and negative 1 million. We cannot set max num equal to 0. If we set it equal to 0, then it will stay 0, and inside this array we never found a 0. If we set it equal to negative infinity, then the maximum will be negative 5,237. Because any number will be better than negative infinity. Okay, cool. So now we have the max number. We also need to keep track of the position we saw that max number. Let's just set that equal to 0. This is fine because we do know it will be a number. There's for sure, since our array for sure has a number inside of it, which we're doing that here. So with this, we know that once we get here, our array 100% sure has elements or numbers inside of it. And if that's the case, then our max number would for sure get updated because every number is better than negative infinity. So since we are certain we're going to find a better number, we also know, or we are also certain that this max position will update. So we can just set it equal to 0. We can even set it equal to 7 or 9. Doesn't really matter because it will be updated. Okay, so now we created those two variables. Now let's actually update them. So let's iterate over the array. So for index in array.length, if the element at the ith position inside the array is greater than max number, then let's update both max num and max position. So let's set max num equal to that element or that number at the ith position inside the array. And let's update max pos equal to I. Oh, whoops, I've been calling it. Let me just change it here so I don't have to change so many things. So for I in array.length, where I is equal to the index. Perfect, so now we have our two max number and max position variables updated. What else do we want to do now? Well, now we want to build out our tree. So if our tree, the current node of our tree is none, then we want to update that node, or we want to create a node at that position, and that node is going to have a value of max num. And then to build out its left subtree, this is where the recursive call comes in. Tree.left is going to equal to this function, but the array is now going to be everything to the, since this is the left, it needs to be everything up to the position we saw the max number. So from 0 all the way to max position minus 1. And then what we're going to pass it since we want to build out a left subtree, let's call it tree.left. And then let's also do tree.right, the exact same thing, but this time passing the numbers to the right of max position. So max position plus 1, and then all the way to the end of the array. And let's give it, since we want to build out the right subtree, let's pass tree.right to that. So we already found the maximum number and the position of that maximum number. And then here we updated the current node we're looking at to be the maximum number in the array that was passed. And then we're recursively filling in the left and right subtree by calling this exact same function that we're currently in, but changing the array to be the subarray to the left of our maximum number for the left subtree and the subarray to the right of the maximum number for our right subtree. Now right here in the end, let's just return our tree. So we have what we built out, and outside of this function, let's just return whatever the function gives us. And we'll pass it nums, which is given to us inside the problem, and none, because the tree is initially set to none. And this is all of our code right here. This is all we need to write. Let me put it here to the left. So it's that simple. That's really all we have to do. It might be a little bit tough if you're not used to a recursive call, but if you are, then you can see how this builds out, and you can see how it all works. So now let's actually write the code. Okay. I don't think. Okay, there we go. So now let's actually build out the code. Let's create that recursive function. We're going to be having the array and the tree, those two arguments. Then now, if the length of the array is less than or equal to 0, let's just return what we built out. Let's just return our tree. Else, let's set our max number. Let's create these two variables. And max position, set it equal to 0. Now let's iterate over nums, over every index in nums. I'm sorry, every index in our array. There we go. Now if the elements at the index I inside of the array, if it's greater than the max number, then let's update max num to set it equal to array of I, and let's set the position of the max number equal to I. Now if tree is none, which it most likely will be, then let's set tree equal to tree node, or let's create a node at that position that has the value of maximum num. Now let's build out its left subtree by passing in numbers from 0 all the way to the max position -1. But here, since I'm writing in Python, this second argument is exclusive. So it gets up to this number. It gets to, it's already doing the -1 for me. So there's no need for me to add the -1 because it's already built into this programming language. And let's give it the left subtree as well. And let's do the exact same thing with the array. And let's go all the way to the end. Now I also don't need to write the 0 because it knows to start 0, and I don't need to write length of array because it knows to go all the way to the end until it can't go anymore. But something you notice here, for this one, I did add the +1. The reason I did that is because when slicing in Python, the first argument is inclusive and the second argument is exclusive. So this max position, it is going to start at that number. But since I don't want that, I need to add the +1. But that's just Python. Let's not get into that. Now let's pass it tree.write as well. And of course, let's just return what we built out. And to solve the question, let's just return whatever that function or this function gives us. Pass it in nums and none as the initial tree. So now let's run this code, see if I made any typos. I didn't. Let's submit it. And it works perfect. All right, if you guys enjoyed this video, then please check our Discord channel, or our Discord server, I'm sorry, because we send out beginner and advanced problems every single day to help you guys get prepared for interviews or internships or just a job. This happened to be one of our advanced problems. We also send out beginner problems for people who are just starting out. We want to cater to everyone, and with these videos, we really want to help you understand how to solve these problems as well. So if that interests you, make sure to join the server. Just click on the look at the description and click on the Discord server link. Other than that, I hope you guys did enjoy the video. Hopefully this helped out a ton. And yeah, thank you guys for watching.